video, we're going to be talking about how to find the length of an arc, or just a piece of the circumference length, and a sector area, or in other words, a section of the area. So if you are familiar with circumference and area, then there's really just one additional step to finding just a piece of the circumference, or a part of the area. All we need to do is find a fraction of our circumference. So to find the length of an arc, we're actually going to find our circumference. You could also do d times pi here instead of double the radius. That would also be the same. Regardless, we're using our circumference formula there. And then we're finding what fraction of the circumference are we finding when we find just a piece of the arc, or length of the arc. So in order to do that, we need either a degree measurement of our arc, or in more advanced math, we use the radian measure of that, or the central angle. As it turns out, the arc length and the central angle are equal, so we could use either. So if we're finding 45/360ths of our circumference, then we can just find our circumference, multiply by that fraction, and we get a piece of our circumference, or the length of the arc. So since we know the radius is 8, we're going to double the radius, and we're going to multiply by pi, or use 3.14 instead. We can simplify our fraction sometimes. In this case, 45/360 could be reduced. If we divide by 45, we get 1/8. So another way to think about this is this arc is just 1/8 of the total circumference. So find your circumference and multiply by this fraction. Throughout the steps, again, you can simplify as much as you want, or you could just multiply straight across here and divide by 360. If you're using a calculator, your calculator won't care. But if you're trying to do this mentally, then it definitely helps to reduce a lot of things as we work. So if we take 1/8 of 16 times pi, we can actually reduce here again and do 16 divided by 8 to get 2. So this arc length is actually 2 times pi, or 2 times 3.14 gives us about 6.3 centimeters. One more time, just a different circle. This time we want to find just this much of our circumference. We're given the angle measure, or the arc measure. And so we're going to say 60/360ths of our circumference. If we reduce that fraction, really what we're finding is 1/6 of our circumference. So here's our circumference in terms of pi. We could divide by 6 to simplify in one more step, and then multiply by 3.14 or use the pi button. Either way, it's approximately 9.4 inches. There are some applications that we can solve involving arc length. One of the trickier ones is if you're asked to find something involving how far the hands of a clock move. The tricky thing about this is that our clock circle isn't measured necessarily in degrees. I mean, we don't think about it in terms of degrees. We think about it in terms of minutes instead. And so a full circle on a clock would be measured in 60 minutes. And so we're just trying to find fractions of 60 minutes in that fraction spot in front of our circumference. Another way to think about it, if you divide your circle up into different values, you could divide it up into 12ths, and just think how many of your 5-minute increments you have. And then lastly, if it's easy enough to visualize, then you can always just write down what you think it is. Like 45 minutes is 3/4 of an hour, and so I can instead use 3/4. Either way you do it, it's all going to reduce down to the same fraction, whether you think about 45/60ths or whether you think about 9/12ths. It's all just 3/4 of our circle. And so if our radius, or the length of the hand of the minute hand, is 10 inches, then we could take 3/4 of double that, take our radius and double it. And so we're taking 3/4 of 20 pi, which is the same as 64ths pi, or also the same as 15 pi. So lots of ways that we could visualize this and do it mathematically. Either way we go, if we do it accurately, we're going to end up with 15 pi as our simplified answer in terms of pi. And then we can multiply by 3.14 or use our pi button and get approximately 47.1 inches. All right, the other part of our lesson is talking about area of a sector, and a sector is just a section of our area, so it's just a pi piece of our total pi here. Notice that our formula is very similar. We're still going to be finding the area of our circle, but this time we're going to be finding a fraction of our area. So the formula is nearly identical, except for we're just finding a fraction of our area instead of circumference. So again, given the angle or the arc measure, we're going to write that out of 360. That'll be our fraction of our area. Let's find our area this time in terms of our radius, since that's what we're given. So we'll square our radius, multiply by pi, and then take a fraction of that. If we reduce this fraction, we have a common denominator of 30. That would be our greatest common factor. So if we divide top and bottom by 30, we get 5/12. 6 squared is 36. We could simplify a little bit further here. 36 divided by 12 is 3. And then 5 times 3 is 15. So our simplified answer in terms of pi is 15 pi. We could use our pi button or use 3.14 to approximate. And we get about 47.12 square centimeters. Be careful with your units. We're talking about area, so we want square units. Doing another one that looks real similar. This time our angle measure is 225 degrees, so 225 out of 360 is the fraction of our area. We have a radius, so let's plug that into our area formula and square that. So 10 squared is 100. If we divide this fraction by 45, we can reduce it in one step. Doesn't matter if you reduce it in multiple steps, as long as you get to the very end here. Final reduced form is 5/8. 8 doesn't go evenly into 100, so we can multiply our top numbers here, 5 times 100, and put that over 8. So this would be our simplified answer in terms of pi. We could then multiply using our pi button. 500 times that, and then divide by 8, and we get approximately 196.35 square inches. So that represents the area of this piece of our circle. Applications involving area, very similar, as long as you can identify the angle measure or the fraction of the circle that you want to find and use your area formula. And we're just doing the exact same thing we just practiced. In this example, we have a sprinkler, and it's spraying water approximately 400 yards away. So that would be the radius of our circle. And then that water or that sprinkler is rotating 120 degrees in some direction. Doesn't have to be this direction. And it says it does that in 4.5 hours. As it turns out, the time isn't really relevant to solving this problem. So we don't really need the time. We're going to take 120 out of 360. That'll be the fraction of our total circle's area. We have our radius of 400, so we're going to square that. We could square 400 and get 160,000. And we could reduce this fraction by actually dividing top and bottom by 120 and get 1/3. So the amount of area that our sprinkler is getting or watering is about 1/3 of the total circle's area. So we'll take 1/3 of our circle's area and use the pi button, and we can approximate it to be about 167,551.6 square yards. So that's quite a bit of sprinkler yardage there. It must be some sort of industrial sprinkler. All right, so there's how we find areas of a section or sector and pieces of our circumference, or in other words, lengths of a tiny arc there.